Hello friends, good afternoon. I am Professor P.D. More. Today we are going to discuss here the practicals related to transformer. In the last week we have seen here the practicals related to the open circuit test and short circuit test on the transformer. Today we are going to understood here the load test on a single phase transformer. First of all, we can understood here, okay, so what is the need of the load test? So what we have find in the open circuit test and short circuit test, that is the by conducting the open circuit test and short circuit test, okay, so we can have the calculation for the iron losses and the copper losses. Means indirectly we are calculating here, that is the whenever we are conducting the open circuit test, okay, so whatever the losses, whatever the consumption of the transformer, that is the iron loss. And whenever we are conducting here the short circuit test, okay, so whatever the consumption of the transformer, wattmeter reading is the copper loss here. But in the practice, whenever we are going to load the transformer, actually considering any type of load, so in the lab we are going to consider here the lamp load, that is the resistive load. So how the transformer will respond whenever we are going to apply here the load? Actually the outcome is that, say, whenever you are going to conduct here the open circuit test and short circuit test, obviously we are getting the losses and we can calculate here the efficiency. Apart from that, say, we have calculated here the regulation. So that regulation was indirect, okay, so by calculation or by something, say, putting here the formula related to R0 X0, okay, so we have calculated here the regulation of the transformer. But in case of loading test, okay, so whenever we are going to put here the load on the transformer, the secondary side voltage may be something change here. So initially, suppose we are going to conduct here the load test on the transformer. Say we have the transformer, that transformer capacity is 1 kVA, operating voltage is 115 volt and 230 volt. So 115 volt is on the LV side voltage, 230 volt is on the HV side voltage. So what we are going to do here, okay, so we will apply here the voltage to the LV winding, that is 115 volt from the source. We can use here the auto transformer to apply here the reduced voltage, because the rating of the transformer, okay, so it may be something 115 volt, but the supply is the 230 volt. So that's why by using the auto transformer we can apply here the voltage to the 115 volt winding, and the 230 volt winding is connected to load side here. So initially we are going to put here the switch in between the load and the secondary of the transformer, and initially, okay, or say at the starting we can measure here the voltage. That voltage is called as no load voltage. And once we are getting here the 230 volt, suppose we are applying here the 115 volt to the 115 volt winding, and on the secondary side we are getting here the 230 volt. So let us consider here, okay, so initially suppose we are getting here the no load voltage as 230 volt, and now gradually we are going to increase here the load, like say 100 watt, 200 watt, 300 watt. As the capacity is 1 kVA, okay, around something say 1000 watt load I can put on the secondary of the transformer. So as I am going to increase here the load, okay, so like 100 watt, the secondary side voltage will be suddenly decrease. Though the load is resistive, okay, so there will be some drop of the drop on the voltage, and okay, so the 230 volt will be changed to 228 volt, like this. Again we can change here the load from 100 watt to 200 watt, 200 watt to 300 watt. So like this, okay, so whenever you are going to increase here the load on the secondary, we observe that the secondary side voltage starts to decrease here. Now the question arises here, okay, why there is something say voltage drop in the question, or in the Viva the question will be asked here, why the voltage is changing on the secondary side. The reason is that, okay, so whenever the secondary is carrying the current, means whenever the current is passing to the secondary, okay, so including the load, so there will be drop across the secondary side. So that drop is the I2 into Z2, okay, so first drop I can consider here, that is the I2 into R2, and second drop is the, okay, so the I2 into RL, okay, so whatever the load I am considering here. So that's why, say, due to this okay, two drops, the secondary side voltage will be something decrease here. Actually this is the effect of the armature reaction. Okay, so you can call this as the armature reaction, because actually it is not like armature reaction, but whenever we are going to consider here the secondary have the parameters, okay, so secondary has the load, secondary has the resistance R2, and okay, so we have the RL also. So when the current is passing through R2 and the RL, so that drop will be considered here, and due to these two drops, finally the voltage across the load will be changing here. So we can increase here the load like 100 watt to 1000 watt, and we can observe here, okay, what is the change in the output voltage. Okay, so that output voltage with the reference of the no load voltage, we can calculate here the regulation as, okay, so percentage regulation, voltage regulation is equal to VNL minus VL divided by VL. Okay, what is VNL here? VNL is the no load voltage, VL is the load voltage, into 100. Okay, you can get here the regulation in the percentage. And okay, what is second outcome you can get here? Okay, so that is the second outcome is the efficiency. So efficiency you can calculate here. Okay, so the input we can measure. If I am putting here the wattmeter on the primary side and wattmeter on the secondary side, so whatever the power shown by the wattmeter on the secondary side, that is output watts. Wattmeter shown by the, or wattmeter connected on the primary side, that wattmeter gives here the reading as the input. So we have the output and we have the input, so we can calculate here the efficiency. We are observing that, okay, so whenever the load is going to increase here, the efficiency starts to increase here. Means whatever the, when we are getting here the okay, so when we are going to put here the load on the transformer, okay, so gradually it starts to increase here, the efficiency starts to increase here. The reason is that, okay, so what we observe here, at what load we can get here the maximum efficiency. Okay, so the maximum efficiency is possible when the copper losses becomes equal to the iron losses. So since the iron losses are constant, okay, so whenever the copper losses becomes equal to, let us consider here iron losses are equal to, like say 150 watt. The instant at which copper losses increases and it becomes equal to the iron loss, at that moment, at that instant, okay, so you can get, you can achieve here the maximum efficiency. Okay, so that is the outcome here. So we can plot here the graph of okay, so the voltage versus regulation, and okay, output watt versus the efficiency. That two graphs we can draw here. Actually in the POE, in the POE exam, the question may be asked here like this: say what is the regulation? Okay, how we can define here the regulation, and what is the significance of regulation whenever you are going to choose here the transformer. See, the question may be asked in the Viva that, okay, so if I have the two transformers, one transformer having capacity of 1 kVA, operating voltage 213/115 volt, then okay, so first transformer has the efficiency of say 92%, regulation is the 8%. Second transformer have the 1 kVA capacity, 115/230 volt operating voltage, then okay, so the efficiency is 92%, and okay, so regulation is say 2%. So which transformer you can choose here? So generally say the transformer having the less regulation, that can be selected here for the quality purpose. So if you are working as an engineer in the industry, okay, so you have to choose the transformer in such a way that the transformer should have the low voltage regulation. Okay, so what is the observation here? Say whenever we have the low voltage regulation, it indicates that the transformer secondary voltage will not drop here much, though you are going to apply here the load. Okay, so such type of questions can be asked in the exam, so you can prepare accordingly. Okay, so thank you so much.